Example 3, finding the probability of independent events. As part of a board game, you need to spin the spinner, which is divided into equal parts. Find the probability of the following events. Letter A, that you get a 5 on your first spin and a number greater than 3 on your second spin. Now, these are independent events. What you spin on the first spin is not going to have an effect on what you spin on the second spin. So therefore, I know that the probability of A times the probability of B will give me the probability of an independent event. So what we want to find here is the probability that I get a 5 on my first spin. Well, there's 8 spaces on the spinner. 5 is only one of them, so that's 1/8. Times the probability that I get a number greater than 3 on my second spin. So that would be a 4, 5, 6, 7, or 8, which is 5 numbers out of 8. If we multiply those two probabilities together, we have a probability of 5/64. Letter B. What's the probability that you get an even number on your first spin and an odd number on your second? Well, even numbers would be 2, 4, 6, or 8, which is 4 numbers out of 8, which we could simplify to 1/2, times an odd number on our second spin, which would be 1, 3, 5, and 7, which is also 4 out of 8, which would simplify to 1/2. So the probability would be 1/4. Letter C, what's the probability that we get a number less than 3 on the first spin? So less than 3 would be 1 or 2, which would be 2 out of 8, which is the same as 1/4, times a number greater than 5 on the second spin. So that could be 6, 7, or 8, which would be 3 out of 8, which simplifies to or multiplies to 3/32. Letter D, that you get a 6 on your first spin. So a 6 on our first spin, there's only 1 6, 1 out of 8, and a 9 on your second spin. Well, there's no 9 on the spinner, which means the probability of that happening is a 0. Meaning the probability that we get both because it said and would be 0 because that can't happen.